Hi everyone, welcome to Bison Maths. My name is Mr. Bison and I've been a maths teacher for the last 10 years and currently work in a school in East London in Bethnal Green. So the idea for this video of the top 5 hardest A-level maths questions came about when I was looking to see what students struggled with the most in their A-level exams. I thought this might help my students in my classroom, and then I thought you might be interested to see what the results of this were. Bit of a disclaimer, these are not my opinions on what I think the hardest questions are, but these are actually from Edexcel's data. I looked at each question and saw what the average mark was that was scored by pupils across the country in these exams, and I worked out then what percentage of the question they had achieved on average. So I'm just going to go through these questions with my solutions. But if you want to find out more about the skills that I'm actually teaching here, I'm going to leave some video links in the description from real lessons that I have taught. And hopefully they may be useful to you. Let me know if you agree with this top 5 hardest questions. I'm not sure I necessarily do, and I want to know if you're surprised at what's in there at number 1. Okay, let's get started. So in position number 5, we have this question from the 2019 Pure Paper 2, and it is the vectors topic from year 1. I have to say I'm not surprised that this one is in here. Vectors is a topic that most students find really difficult, and this one is particularly challenging. So the average mark that was scored on this one was only 33%, and you can see here that there are actually just 6 marks available. So I'm going to go through this, and I'll also link a video that might help you to study more of these types of problems. So it says, the figure 7 shows a sketch of triangle OAB, and the point C is such that OC is equal to 2OA. So I can actually plot where C is going to be, because it's going to be 2 lots of this journey, so it's going to be somewhere at this position that I've got here. I'm just going to do it kind of roughly on the diagram. The point M is the midpoint of AB. So I'm also going to plot this point here as M, which is the midpoint. And then it says the straight line through C and M cuts OB at the point N. So I'm going to draw a straight line through C and M, and it's going to cut the line OB at N. And this place here is N. And it says, given that OA is equal to A and that OB is equal to B, find CM in terms of A and B. So I'm going to try and find this journey from C to M. Well, I also know that this vector is going to be A as well because of what they told me earlier on. So it looks like I'm going to need to try and trace a journey. Now, I think the best journey to go from C to M is going to be to go from C to A and then from A to M. And in order to go from A to M, I'm going to need to find out what A to B is. So for part A of the question, it wants me to find out what CM is. I have decided the best way of doing that is going to go from C to A and then to go to AM. But in order to go AM, I can see that AM is going to just be a half of AB. So I better figure out what AB is. AB is just going to be B minus A. You can just see that from the diagram. So we should be able to now actually work out what CM is actually going to be. CA is just going to be minus A. And I'm then going to add on a half of AB, which is B minus A. And what we've got left with here is then minus A plus a half B minus a half A. And that all simplifies to minus 3 over 2A plus a half B. Now, I think that's an awful lot of work just for 2 marks, but we have got those 2 marks at this stage. Now, I think this was where the question got really challenging, so I'm going to come back to the diagram. It says, show that ON is equal to this rather complicated looking thing that we've got written here, where lambda is a scalar constant. So we're trying to say the journey from O to N, and we're going to try and say that journey using what I think part A has asked us to do. So if I want to try and go from O to N, and they've already got us to work out what CM is, I think I'm going to take this journey to get all the way to N. I think I'm going to go up to C, and then I'm going to come this extra bit of distance down here, which I'm going to sort of do in a slightly different colour. Now, what we should recognise here is that the vector Cn is going to be some multiple of the vector cm, because they are parallel to each other. And I think this is where that lambda is going to be appearing. So it looks like that the vector on is going to be oc plus cn. Let's do that for part B of the question. We're going to say that the vector on is going to be oc plus cn. And we did just say here that cn is some multiple of cm. So I'm going to continue on to the next page here. OC is going to be the vector from here to here, which is 2a. So we can say that we have 2a plus lambda lots of cm. Now cm is this thing that we just worked out here. So I'm just going to substitute that in, and we get minus 3 over 2a plus a half b. Now when I simplify and expand, I'm hopefully going to come up with what they had. So that's minus 3 over 2 lambda a plus a half lambda b. Now, does that look similar to what they've got? It looks like it could be. Let's see if we can just keep working on that a little bit more. I'm going to factorize out the a, so I have 2 minus 3 over 2 lambda, and then I've got my half lambda b as well. And this thing that I've just worked out here is indeed what they asked us to work out in the question. We've got that 2 minus 3 over 2 lambda a plus a half lambda b. Very difficult just for 2 marks though. I think this is a super tough question. Part C of the question then says, hence prove that on to nb is 2 to 1. Now, if you've seen my videos on comparing coefficients before, you'll know that the strategy for this is to find on in 2 different ways. I'm actually going to say 2 different pathways, and then compare the coefficients. So they've already told us what on is, which is this green bit that I've got here, but I'm now going to try and find out what on is in a different way. Well, when I look at this diagram that I've got here, it looks like, if I use a highlighter in blue, that on is some fraction or some multiple of OB. So I'm actually now going to say that on is another multiple mu of OB. And we know what OB is because it is B. So the second way that I can calculate what on is for part C of the question is that on is some other multiple or some scalar constant of the vector OB, which is just mu multiplied by B. Now I have got 2 things that on is equal to. From the previous part of the question, on is equal to this. And what we've just worked out is that on is equal to this. So I can now say on must be equal to on. In other words, mu b equals 2 minus 3 over 2 lambda a plus a half lambda b. And here is where we compare the coefficients. So if I look at what is in front of b, I have mu and a half lambda. So they must be equal to each other. So mu equals a half lambda. And when I look at this other bit that I've got here, I can see that the a coefficient on the right-hand side is that, and on the left-hand side, there is no a coefficient. So actually I have that 0 from the left-hand side is equal to 2 minus 3 over 2 lambda. Looks like I can now solve this equation on the right-hand side. So 2 equals 3 over 2 lambda, which means that lambda is equal to 4 over 3. And then if I go back to this other one that I have up here, I can say that mu is equal to a half of lambda, which is 4 over 3. And so mu is equal to 4 over 6, which is 2/3. Now this is going to be the important part to help us answer the question, because we have now said that mu, the fraction along OB, is 2/3 of the distance, and this is 1/3 of the distance. So in order to come up with the bit where it says that on to nb is 2 to 1, we can now say that on was a vector mu b, which is 2/3 b, and then b is a vector which is 1/3 b. So the ratio is just going to be 2 to 1 for that last part of the question. Now, I think that is complete madness for just 2 marks, and it's one of the most challenging types of questions that you can have on vectors. Okay, in at number 4 is this question from the 2019 paper again from Pure Paper 1, and it is a mix of questions. There's a proof part and there's a functions part. I have to say, I was pretty surprised that this one was in the top 5. This is telling me that proof is something that my students are not very good at, and I think that students across the country are probably not as good at. It tends to be because we don't really know how to get started on these kinds of questions. So hopefully we can break down that first part of the question together. You can see here the average percentage on this 6-mark question was only 29%, so not very well answered at all. But let's dive in. So question 10, part 1, it says prove that for all n as a member of the natural numbers, n squared plus 2 is not divisible by 4. So for question 10, part 1, this is actually a proof by exhaustion question. The reason I can tell it's a proof by exhaustion question is because it wants us to know it for all values of n. So I'm not going to do it for all values of n. I'm in fact going to just investigate if n is even and if n is odd. If I can check with even and odd numbers, then I've been able to prove that it's true for all values of n. So first of all, if n is even, then n equals 2k, where k is an integer. So I can now work out what n squared plus 2 is. Well, it would be 2k squared plus 2, which is 4k squared plus 2, which is trying to show that it's not divisible by 4. If I take out a factor of 4 from that beginning part, I can clearly see that there is 2 extra. So n squared plus 2 is 2 more than a multiple of 4. So it's not divisible by 4. Now I'm going to see what happens if n is odd. So if n is odd, then n equals 2k plus 1, where k is an integer. So I'm going to investigate what n squared plus 2 is. Well, it would be 2k plus 1 squared plus 2. I'll expand the brackets to get 4k squared plus 4k plus 1 plus 2, which is 4k squared plus 4k plus 3. And clearly when you take out a factor of 4, you're going to have just the k squared plus k plus 3. So here, n squared plus 2 is 3 more than a multiple of 4. So it's not divisible by 4. Now all we need is a concluding sentence. We've shown it's not going to work with the evens or the odds, so it doesn't work for any. So because n squared plus 2 is not divisible by 4 for when n is odd and when n is even, n squared plus 2 is not divisible by 4 for n as a member of the natural numbers. The natural numbers are just the counting numbers there. So that's a 4-mark question, and it's a proof by exhaustion. Split it into the evens and the odds, and then see how it goes. Okay, so for 10 part 2, it's only a 2-mark question, and they really like these always true, sometimes true, never true kinds of questions. So it says, given that x is a member of R, the value of the modulus of 3x minus 28 is greater than or equal to the value of x minus 9. State, giving a reason, if the above statement is always true, sometimes true, or never true. Well, it's only 2 marks here. If it was always true, we'd need some kind of proof, or never true, we'd also need some kind of proof. So I'm going to gamble on it being a sometimes true sort of thing. And I think what I'm going to do is write the inequality of this, and I'm going to try and solve that inequality. So let's have a think about what that's going to look like. The question is, for 10 part 2, that the modulus of 3x minus 28 is greater than or equal to x minus 9. So I'm going to begin by actually just solving the equation 3x minus 28 is equal to x minus 9, and that's going to produce two equations. It's either going to produce 3x minus 28 equals x minus 9, or the negated version of this, which is 3x minus 28 equals x minus 9. With a quick bit of equation solving, here we get that 2x is equal to 19, which means that x is equal to a half of 19, which is 9.5. With some equation solving here, we're going to get something a little bit different. So we get 4x equals 37, and so x is equal to 37 divided by 4, which I already had there, which is 9.25. So it seems like that they are going to be equal to each other when x is 9.25 and 9.5. So we've got a bit of a range of the values now of something to do with 9.5 and 9.25. My guess is I'm going to try something inside the range, and then I can try something outside the range. So inside the range, let's let x equal 9.3. So the left-hand side would be 3 times 9.3 minus 28. So that's 3 times 9.3 minus 28, which is minus 0.1. But when I take the modulus of it, I will get 0.1. And the right-hand side is going to be x minus 9, which is 9.3 minus 9, which is 0.3. So clearly here, we now have that the left-hand side is less than the right-hand side, so statement is false. Now I'm going to try something that's outside that range, so I'm going to try something really easy. I'm going to just let x equal 0. Then the left-hand side would be 3 times 0 minus 28, take the modulus of that, which is just going to be 28, and then I'm going to do 0 minus 9, which is minus 9. And so clearly here, the left-hand side is bigger than the right-hand side, and so the statement is true. Hence, the statement is sometimes true. Now, the reason I knew to try something inside the range and something outside the range is just my knowledge of modulus graphs. I know that one of the modulus graphs is going to be that kind of V shape. I've then got another graph which is going to have a positive gradient. So it looks like there's going to be some areas where the modulus graph is bigger and some areas where the modulus graph is smaller. You could do this whole question using graphs, but I quite like doing it in the algebraic method. So do I think this should be in the top 4? Well, I do for part 2 of the question, but I don't for part 1 of the question. I think part 1 of the question is actually pretty easy if you just learn your proofs. I think part 2 of the question is more challenging, especially just for 2 marks that you've got there. Okay, in at number 3 is this really horrible question. And I remember my students coming out of the exam hall after they'd taken this one, and some of them were in tears because they just had no idea what this question was about. So it was from the 2019 Pure Paper 2, and I haven't even told you what the topic is because that's the big trick with this question. Only 28% of marks on this 3 marker were actually scored. And it says here that figure 3 shows a sketch of the curve with equation y equals root x. The point pxy lies on the curve. The rectangle shown shaded on figure 3 has height y and width delta x. And then suddenly they're asking you to calculate the limit as delta x approaches 0 of the sum of root x delta x from x equals 4 to 9. So what's actually happening here is this is the discrete version of integration. It's actually saying this little bit that we've got written down here, root x delta x, is actually representing this rectangle that we have here. The summing symbol that we've got is asking you to sum up all of these rectangles that would be inside this shape between 4 and 9. And this limit part of delta x going to 0 is saying, imagine that this thickness of the rectangle is going to get thinner and thinner and thinner and thinner, until instead of it looking like a bunch of rectangles all stacked next to each other like this, that it's actually just going to become the shaded area underneath that. And so this is actually just an integration question in disguise, and I was not happy to see this one because I really felt like it was very unfair. But interesting side note, this sigma notation is the discrete version of summing things up. This notation is the continuous version of summing things up. So actually, this bit that we've got written here is just going to be the same as the integral between 4 and 9 of the square root of x dx. So that's all this question wants you to do, and I think that's why this is in the top 5. So let's actually just answer this question. We're going to now just work out between 4 and 9 the integral of the square root of x dx. Very, very easy once you know what to do. We're just going to raise the power to 3 over 2, multiply by the reciprocal of that power, which is 2/3, and we're going to substitute in the limits from 4 to 9. So that's going to be 2/3 of 9 to the power of 3 over 2 minus 2/3 of 4 to the power of 3 over 2. Now I'm feeling lazy here, so I'm just going to do 9 to the power of 3 over 2 on my calculator, which is just 27. So it's 2/3 times 27 minus 2/3 times 4 to the power of 32, for 3 over 2, which is just 8. So that's going to be 2/3 times 27 minus 2/3 times 8, and we come up with the answer 38 over 3. Not a nice question. Asked in a completely bizarre kind of way. The examiners since said that they think that this is in the specification. I'm not sure I agree with them, but I have taught my students about this just in case it ever comes up again, which I don't think it should do. Okay, in at number 2 is this horrible mechanics question from 2019 paper. You can see that the 2019 paper has pretty much dominated the top 5, and it's a rigid bodies or moments question. This was a 10-mark question, and the average number of marks was 25%. If I just zoom out for a second, I think you'll see this is a pretty intimidating looking question with an unfamiliar looking diagram and a lot of text that's written there. So let's just read through this, and we're going to try and break this question down. So it says, a ramp AB of length 8 meters and mass 20 kilograms rests in equilibrium with the end A on rough horizontal ground. The ramp rests on a smooth, solid, cylindrical drum, which is partly under the ground. The drum is fixed with its axis at the same horizontal level as A. The point of contact between the ramp and the drum is C, where AC is 5 meters as shown in figure 2. The ramp is resting in a vertical plane which is perpendicular to the axis of the drum at an angle theta to the horizontal, where tan theta is 7 over 24. The ramp is modelled as a uniform rod. Explain why the reaction from the drum on the ramp at point C acts in a direction which is perpendicular to the ramp. So this question was really, really badly answered, but we know here that there's going to be a reaction at C, and this is what it's talking to us about, and it says, why is that going to be perpendicular to the ramp that we have here? Well, if there was actually some friction on the ramp, it's going to be the whole thing is going to be trying to slip down in this direction, the ramp, which means there would be some friction in this direction, which means that the overall normal reaction that we have would actually be going off at some kind of angle like this. So the reason that there is the reaction from the drum on the ramp is perpendicular to the ramp is because the drum is smooth. And I'm just going to highlight that in the question. It says here, if I can find it, there it is. The ramp rests on a smooth, solid, cylindrical drum. So it's the fact that it is smooth. So because the drum is smooth, the reaction force is only from the normal reaction, and hence is perpendicular. Okay. Then here comes the mammoth 9 marker. It says find the magnitude of the resultant force acting on the ramp at A. Okay, let's have a look at the diagram that I've copied and pasted down here because there are a lot of things that are going on. First of all, the forces that we've got, we know that there is a reaction force at C, which I'm going to just call N. I called it R earlier on, but it doesn't really matter. There's also going to be some forces that are happening at A. There's going to be a normal reaction that is going upwards like this, and there's also going to be some frictional force that is going to the right like this because the ramp is going to try and slip down. You know what? I think I'm actually going to change these from X and I'm going to change it to X and Y. I'm going to have it going upwards with Y and going across with X. We've also got the mass of the whole thing, which is 20 kilograms, and because it's a uniform rod, it's going to be acting in the middle, and it's going to be 20 G of it coming downwards like this. I'm not sure there are any other forces that we should be taking into account here, but I do want to use the fact that tan theta, I'm just going to double check this, was equal to 7 over 24. Now, if tan theta is 7 over 24, you can work out that sine theta is 7 over 25 and cos theta is equal to 24 over 25. There's only 3 things you can actually do in these questions. 3 things? I think only 2 things you can do. You can either resolve, I can say 3 things. You can resolve up and down, you can resolve left and right, and you can take moments. So we're going to have to do all of those things to try and find out what's going on here. Now I have got some angled forces, and this angled force that I've got here, which is N, I'm going to split into 2 different forces. I'm going to split it going upwards and then going to the left here. And this angle is also going to be theta. So this force going upwards is going to be N cos theta, and this one going to the left is going to be N sine theta. So I'm just going to go ahead and start doing some of the resolving that we've got. I'm going to begin by resolving left and right. This means that N sine theta is equal to X. And then we are going to have that N cos theta for resolving up and down. In fact, I may do a little bit of work on this first because I know that N sine theta is going to be 7 over 25 N. Is equal to X. Let's take this and move it down. Resolving up and down, I can now see that Y plus N cos theta equals 20G. So Y plus N cos theta is equal to 20G. And that is going to be Y plus 24 over 25N equals 20G. So I'm actually going to be interested in this question. I'm trying to find out what this reaction force is that's at A, and that reaction force is going to be the combination of Y and X. So that reaction force that I have here, if I find out what X and Y are, I'm then going to be able to find out what the reaction force is by doing Pythagoras. So I am now going to try and do the third thing, which is going to be to take moments. And I think the most sensible place to take moments about in this question is going to be A, because then I won't have to deal with X or Y, I'll just have to deal with the other forces that I've got. So I'm going to zoom out so I can see the diagram whilst I'm doing this. I'm going to take moments about A. Now when I take moments about A, one of the forces is already perpendicular, which is N. So I'm just going to be doing N, the force, multiplied by the perpendicular distance, which is 5. And then the other one is going to be a little bit trickier. So I've got that the force is 20G. I just need to work out what the perpendicular distance is. So the perpendicular distance, which I'm going to highlight in yellow here, is going to be from this triangle, where this is theta and the hypotenuse is, oh, it's not going to be 5, it's going to be 4, because this is acting in the midpoint. And so the distance that's running along the bottom is going to be 4 cos theta. So it is going to be 20G, the force, multiplied by 4 cos theta, which is the perpendicular distance. And this is great because I can now find out what N is equal to. So 5N is 20G times by 4 times 24 over 25. Okay, so I'm now going to finish by finding out what N is equal to. So I'm going to say what 5N is. put it all in my calculator. So it's going to be 20 times g times 4 times 24 divided by 25, which is 752.64. And so n is going to be equal to that divided by 5, which is 150.528. So I'm nearly there. I just need to figure out what x and y are. Well, x is 7/25 of n. So I'm going to do 7/25 multiplied by 150.528. And I'm going to run out of space. That's not good. Let's just quickly see if I can put that in the calculator. So we're going to do that answer multiplied by 7 divided by 25, which is 42.147. We also know from our earlier on calculations that y is equal to 20g minus 24 over 25n. So I can calculate what y is equal to. So it's going to be 20 times g minus 20 multiplied by n divided by 25, and y is equal to 51.493 blah blah blah. So the last step is to find out what the reaction force is. The reaction force is going to be the square root of x squared plus y squared because of Pythagoras that we have acting at this spot here. All I need to do now is calculate what this is going to be. So it is going to be the square root of that answer squared plus 42.147 squared, and we get an answer of 66.5 newtons. So we have the answer of 66.5 newtons to 3 significant figures. What a crazy hard question. Last thing we want to do for part C, it says, given that the center of mass of the ramp is assumed to be closer to A than B, how would this affect the magnitude of the normal reaction? And it says state how it would affect the normal reaction between the ramp and the drum at C. So if you imagine this becoming heavier down at this end, it means that it's going to be pressing less hard on C, which means the normal reaction at C is going to decrease. So you could have just had a guess for part C. You could say this will decrease the magnitude of the normal reaction at C. And you can just guess that because it just says a state, but it's not a guess. We can see that it's going to make there less pressure on that particular point. A pretty tough mechanics question of a pretty tough topic. I've got lots of examples similar to this in other videos. Okay, so here it is, the number one hardest question from the most recent Edexcel new specification exam. In at number one, you probably guessed it, it's statistics. It's the only question from the 2018 paper, and it is a question on the large data set. Now, I did explain that these questions, I don't necessarily know if I think they're the hardest ones. This was also the first time the large data set was ever asked about, so it's possible people didn't really have a clue of what was going on, or it's possible that people just don't like statistics and they don't put much time into it. So let's have a look. Number one from the 2018 statistics paper, it is the large data set. And it says here, the first question in the exam, and only 19% of marks were scored on this. Helen believes that the random variable C, representing a cloud cover from the large data set, can be modelled by a discrete uniform distribution. And the first thing it wants you to do is to write down the probability distribution for C. So there are two things that you need to know about, is that cloud cover is measured in octaves, and it goes from a scale of 0 to 8. And a discrete uniform distribution is, the most important word is that uniform, because that's going to refer to the different probabilities. So all you needed to know for this is that you could say that your random variable C, we could put along the top here, it is either going to be 0, 1, 2, 3, 4, 5, 6, 7, or 8 octaves, and the probability that C is equal to C, this is a little c that we've got at the top here, should have made it a little bit smaller, is just going to be uniformly distributed between these different octaves for clouds. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 spots, so each of those probabilities is going to be 1/9. You may think that with octas, the probabilities were going to be an eighth, but obviously there could be 0 clouds in the sky. In case you're not sure what the octas are actually measured by, there's like a grid that has got 8 spaces, and you hold it up to the sky and you see how much of the grid is being covered by clouds, and you can have anything between 0 and 8. So this is a discrete uniform distribution. It's discrete because there are discrete different options you can have for the cloud coverage, and it's uniform because all of the probabilities are the same. It then says, using this model, find the probability that the cloud cover is less than 50%. So I want to know, what is the probability that the cloud cover is going to be less than 50%? Well, this is where you need to know that 4 means 50% of the sky is cloudy on the octa scale. So we're actually asking for the probability that the clouds are less than 50%. So we want it to be less than 4, which is the probability that C is less than or equal to 3, which is just going to be these probabilities that we have here, which I'm going to highlight, 1, 2, 3, 4. The probability of that is just going to be 4/9. And you may know that 4/9 is 0.444 recurring, okay? Then it says that Helen used all the data from the large data set for Herne in 2015 and found that the proportion of days with cloud cover of less than 50% was 0.315. Comment on the suitability of Helen's model in the light of this information. So Helen's model is this one here, and it predicts that there would have been a 44% chance. So Helen's model predicted 44% of days with less than 50% of cloud cover. This is much higher than the reality of 31.5%. So is Helen's model good? No. So Helen's model does not seem suitable. Last thing, it says suggest an appropriate refinement to Helen's model. We could say something like, because cloud coverage will vary by month, Helen should not use a uniform distribution. And instead, vary the probabilities. So only 19% of marks were scored here. I'm hoping that this isn't really the hardest question. I'm hoping that this is just a representation of the fact that people don't know the large data set very well. They don't know about cloud coverage and octas. And also the people who do maths generally don't like to do these kind of worded questions of having to write sentences. So if you know that the stats questions are pretty difficult, this is probably going to be something you're going to want to fill in your revision with to make you have an edge over other candidates. Okay, just in case you were interested, I've also got here the data from all of the questions from 2018 and 2019, so you can get a sense of how difficult some of the other questions were. We've already dealt with these top 5 here, and then you can see you've got a big chunk of 2019 papers, but 2018 starts to creep in. You'll see stats is pretty high up in here, and as we go down to the easiest questions that are at the bottom here, the easiest questions tend to be from 2018. 2019 was a horrible, horrible exam paper. So if you're interested in looking for what was the easiest question, it was question 2 in the 2018 Pure Paper 1. Okay, so that's it for the top 5 hardest A-level maths exam questions for Edexcel. I think it's been really useful for me as a teacher to know what are some of the things that students across the country aren't doing so well on. Hopefully it's been really useful for you as well. If you'd like me to make anything similar to this, I'm happy for any suggestions. Otherwise, check out some of the tutorial videos on my channel. Make sure you're subscribed, and I hope that they're useful for you. Thanks, guys.